Let's take a look at negative exponents in scientific notation. I'm going to split this up into a couple videos. All right, let's just focus on the negative exponents part, and then we'll see kind of an application of it with scientific notation. All right, we hinted at negative exponents in 5.1 when we looked at this problem. All right, and we said, let's treat this like we did before. All right, spell out what's going on. And do a little canceling, or simplifying. And we saw, yeah, we just really need to find the difference between these two, and we end up with y to the third power. But those extra 3 y's are in the denominator, with everything being simplified in the numerator, meaning there's just a 1 left over. So that's a perfectly good answer, and in fact, it's the best answer for us to use. In fact, even MATLAB will make sure, it'll say, make sure you write your answers with positive exponents only. So that's the ideal answer, and if we can look at this and come up with y to the third, that'd be great. But we do need to know where negative exponents come from, and they do come from this situation. It's just evaluating this problem differently. We do have 2 y's on the top, and we're trying to divide by y to the 5th. So we just treated this normally and said, okay, I'm going to take my numerator's exponent and subtract my denominator's exponent. We could treat it as 2 minus 5. 2 minus 5. The division acts as a subtraction sign. Right, if we did it this way, now we can see where this negative exponent comes from. Right, it comes from just subtraction. We just, we didn't focus on where there were more y's or where there were less y's. We just said, I know this means top exponent minus bottom exponent. This is also a correct answer, but in the scheme of things, it's not the greatest, because if I ask you to find or evaluate what 2 to the third power is, if I ask you to do this, this should be not a problem at all. Right, we know that 2 to the third is 2 times 2 times 2, and we can come up with an answer of 8. Right, if I ask you to tell me what 2 to the negative third power is, there's probably going to be more of a hesitation, because what does it mean to be a negative exponent? Excuse me. Right, this is not a very useful format, because trying to plug in a number and raise something to a negative power isn't an intuitive thought for us. Right? It's something that we haven't used a lot or seen a lot, so we don't really quite know what it means. So this is hard to tell. It's not intuitive. The answer is not -6. The answer is not -8. Those are 2 things that you might think it is. Right? That's why it's easier to think of it as this. If I asked you to evaluate 1 over 2 to the third power, these are in fact the same. Right? We saw that they're the same. Right? This is going to be a little more easier because we know how to do 2 to the third. It's in the denominator, so 2 to the third is 8, so this would be 1/8. Right? So it's hard to figure out what something is raised to a negative exponent unless we write it with positive exponents. That we know how to handle. So we might be able to come up with a conclusion here based on seeing this. If 2 to the third is 8, and 2 to the negative third is 1 over 8, this kind of hints at what our definition of negative exponents will be. Right? These 2 statements are exactly the same. So a negative exponent kind of acts like a reciprocal. Right? It's going to say, well, I don't like this term with a negative exponent. Let me flip it upside down, and I can make it a positive exponent. So we are essentially kind of reciprocating this, this expression. So let me write that down. All right, so here's our more formal definition of negative exponents and how we can use them. And we can say, okay, if I have a base that's raised to a negative power, I can just flip it upside down and raise it to a positive power. Right? We're going to reciprocate it and flip it upside down. Or, alternatively, if I have a negative exponent that's in the denominator, I can say, well, I don't like that negative exponent in the denominator. Let me reciprocate it and move it up to the numerator. Right, and we'll call it a positive power. Right? So So these are our two ways to look at negative exponents, okay? And we're just going to change them to positive exponents. Once we have positive exponents, we know how to handle that scenario. It's much more it's like in our comfort zone. So we want to turn these little nastier problems into a more comfortable scenario. That's the goal. All right, let's try to put that in practice with a few more complicated examples. So let's simplify. And use positive exponents only. All right, so we can start pretty simple, right? Just getting used to this idea. So if I had a to the negative 7th power, that's pretty simple, but it's not the nicest way to look at this. So we're just going to be applying one of our properties here. All right, if I don't like the negative exponent, we can rearrange it and say, okay, I'm going to drop it to the denominator. All right, now we have a positive exponent, and that is a simple, more simplified form, one that's easier for us to use. All right, same goes here, just another role reversal. Just using this property of exponents. If I have a negative exponent in the denominator, I can say, I don't really like it there. I'm going to rearrange this, right, put it in the numerator, and make it a positive exponent. More elaborate example, but really there's nothing different. Just like before, you deal with each variable, each base independently. And if I wanted to rewrite this and simplify and use positive exponents only, well, if a base already has a positive exponent, I don't want to change it at all. A to the 5th I'm happy with, d to the 4th I'm happy with. Those are positive exponents. It's these two pieces to this puzzle that I don't like. So if I'm going to rewrite this, I'm going to treat it as one big fraction where my numerator keeps the pieces that I like. Right, but my denominator is going to grab these pieces that have negative exponents and bring them down. We're going to reciprocate these, and these are going to drop to the denominator. Okay, so a to the 5th, d to the 4th, over b to the 3rd c. So all we're really doing here to simplify these guys is to rearrange the expression. All right, I'll just do another example here. If I had, let's build up to something a little more difficult. X to the negative 3rd, y to the negative 6th, z to the negative 4. Over x to the negative 8th, y to the 3rd, z to the negative 1. All right, so I'm going to do this in 2 steps. I think it's a little bit easier to, if I see negative exponents all over the place, I'm going to immediately want to, let's just rearrange this and only deal with positive exponents, kind of like we did here. We're just rearranging first. So I don't want to try to simplify my x's yet. I'm going to rearrange everything. Right? Negative exponent is going to want to drop. This negative exponent is going to want to jump to the top. So all my negative exponents are going to want to change place in the fraction. And I do have one positive exponent down here, y to the 3rd. It's positive, so I'm going to leave it where it is. Right? You're not flipping everything around. You're just flipping the individual pieces if they want to be flipped, if they have a negative exponent. This guy's going to stay. All right, so if we rewrite this big fraction in the numerator now, the x to the negative 8th would be up, become x to the 8th. The z to the negative 1st would go up, become z to the 1st. All right, in the denominator, right, all these negative exponents from the numerator would drop, so we'd have x to the 3rd. Right, this y to the 3rd is still there, y to the 6th, and z to the 4th. Right, now we can treat this, since we all have positive exponents, we can treat it kind of like we did over here, right? Just kind of a comparison technique. When I'm looking at my bases of x, right, when I compare the exponents, right, which side has more? The numerator. How many more x's are in the numerator than the denominator? We're finding the difference here. So how many more? There's 5. So when I answer this question, I'm going to have 5 x's left in the numerator. All right, if I go to my y's now, right, all my y's are in the denominator of this problem. I have 3 y's here and 6 y's here. They're all grouped together in the denominator. They're being multiplied down here. So I'm going to add the powers. I have a total of 9 y's in the denominator. And when I look at my z's, I have 1 z in the numerator, 4 in the denominator. So now they're canceling each other out. And we're trying to find the difference here. Okay, so comparing these two, there are more z's in the denominator, and there happen to be 3 more z's. That's the difference. So I should have 3 z's left over, and that would be a final simplified form. They all have positive exponents. We took care of all the negatives from the get-go, and then used our comparison technique, like right from the beginning, to find out where those extra variables are left over. All right. So that's the majority of dealing with negative exponents, maybe a couple other examples to cover all the topics. All the types of questions. A couple other quick questions if I had. Something like this. If I have a power to a power, right, this goes back to our properties of exponents. Remember, when you have a power to a power, you want to multiply those exponents. So I would get rid of this parentheses and raise things to my powers right away. So I have y to the negative 4th and the negative 2nd. Multiply these, I end up with y to the 8th. All right, and remember, coefficients work differently. This guy has an exponent of 1, so if you wanted to go ahead and write this, that would be 1 times negative 2. So this is 3 to the negative 2nd power, which is what we would expect. Coefficients are actually happening like normal. This is 3 to the negative 2nd power, so I'm just writing that down. So y to the 8th is fine, right, in reality here. We don't want to change that. These two negatives became a positive. That's a happy piece to this puzzle. Right, but 3 to the negative 2nd is the piece we want to change. So we can rewrite this fraction as y to the 8th. Right, this guy will drop to the bottom and become 3 to the 2nd. And we can even go further and simplify what we can, because I know what 3 to the 2nd is. That's 3 times 3. And it should be 9. Y to the 8th over 9. So a little more complicated when you raise it to an exponent, but again, break it down into little pieces that we know how to do. We're not doing anything new here. Just combining all these properties together. Right, maybe one other problem I had. Something like this. All right, in this situation, all right, you could, all right, apply this negative 5 to everything in the parentheses, 7 to the negative 5th, y to the negative 5th, 7 to the negative 4th, y to the negative 4th. You could do that, right, but it might be easier just to say, well, let's handle these negative exponents all together and make them positive. Right? This negative exponent should rise up. This negative exponent wants to be in the denominator. So we might take this approach here and say, well, this negative exponent comes up, this negative exponent drops down, in which case, and now we're only dealing with positive exponents, and this probably looks more complicated than it actually is. right? But 7y is acting as a whole base. They both have the same base, so we don't have to overthink this. Right? This is some base to the 4th power and some base to the 5th power. Right? Just like over here, I've got some base to the 2nd and some base to the 5th. We know that these powers should just cancel out and we'll be left with a certain amount. So in this case, if these powers canceled out and we compared them, well, clearly we have more of these bases in the denominator than the numerator. How many more? Just one. So I have 7y, right, technically to the 1st power in the denominator because these canceled out, and I have none left in the numerator. Right? Easy way to write that though, since it's just to the 1st power, is I guess I don't need parentheses and I don't need a power. So we can just say that's 1 over 7y. Okay, so in a couple trickier scenarios, but as long as you're being very careful of what the negative exponent applies to, it should apply to everything in parentheses. We should be able to handle that all right.